James Swift. I'm an engineer at PSPDFKit.
I'm Giuseppe Gurgone. I'm an engineer at PSPDFKit too.
Yeah, and we're joined today by Alon Zakai. I hope I pronounced that correctly. One of the co-creators of WebAssembly and creator of Emscripten. And we want to chat a little bit about WebAssembly, what it is, what it's good for, and why you should be using it. So welcome.
Sounds good.
So yeah, again, thanks again for making the time to join us. We'd like you to just, can you give us a little bit of a small history of how WebAssembly came to life?
Yeah, sure. So WebAssembly, I think, tries to solve the problem of running code in browsers at really full speed, close to native. And so JavaScript is very fast, but there are things like large native applications that it doesn't quite match native speed. So WebAssembly tries to fix that. How I personally see the history is kind of there was an understanding that this is an important area, and browser vendors tried to do different things like asm.js and native client, and eventually just all browsers came together and decided to standardize something. So that was in around 2015, and that's really how WebAssembly came to be. So it tries to be better than the previous things, and also kind of a thing that lets you avoid plugins like Flash, lets you just use standard web technologies, but still get sort of high-speed applications on the web.
Right, and I guess there was some inspiration there from asm.js and Pinnacle before that.
Yes, exactly. Yeah, I mean, they each took kind of a slightly different route, and I think ideas from both informed the WebAssembly standards process. So it's kind of similar to asm.js in some ways, like the way it interfaces with JavaScript is similar, it has direct access to it, but it's similar to Pinnacle in other ways, the fact that it's kind of a new standard, not built on JavaScript, but designed from the beginning to be fast.
Yeah, right. And like you said, initially, like asm.js WebAssembly was more examples were typically games, like especially games built on Unity and CPU intensive stuff. And probably we were one of the first companies to use WebAssembly for a commercial product that was in a different segment, like productivity software, which has its application, as we've seen in the past years, then like with AutoCAD and design tools, like compiling their libraries to run them in the browser. And for the ones that they're not familiar with PSPDFKit, and what we do is basically a framework for to work with PDF files, and we offer like an SDK for every platform: iOS, Android, Windows, and web. And all the platforms use a common core PDF engine to parse, render, modify documents. And this is like 500K plus lines of C and C++. So initially the web product used a server, came with a server component that ran the PDF engine, and the client would use the server to work on files. And for example, the server would render pages, see images, extract text, and things like that. But when WebAssembly came out, we spotted an opportunity there to basically compile our engine and ship it in the browser. And that's what we did in 2017, I think, with the first version of PSPDFKit for Web Standalone. And that's when we also learned about Emscripten, which is your other creation, I guess. And it's the toolchain that we use to compile our PDF engine to WebAssembly, and also to produce the asm.js that we use for fallback. Would you like to tell a little bit about Emscripten and what it is, why you built it, and what problem solves?
Yeah, sure. So Emscripten started in 2010, which is way before WebAssembly. The original thing was I had a game engine that I had worked on, and I wanted to run it on the web. So I kind of looked around for options, and there weren't many back in 2010. So I thought about that I'll just try tinkering around with LVM and see if I can get it to compile. So I was both interested to compile a game engine, but also kind of curious what kind of technical problems I'd run into, because I just like interesting puzzles I was thinking. So it started that way, and it was just a tool that compiled LVM into JavaScript. And kind of over time, it succeeded in porting things like Python and a bunch of small game engines. And so kind of showed that this approach of compiling to JavaScript could work. And that led to asm.js, and eventually, of course, WebAssembly is something that we do. So Emscripten started compiling to JavaScript, then compiled to asm.js, and now compiles to WebAssembly. So it's kind of at a bunch of different backends along the years. But it always had sort of the core idea, which is to let people port native applications to the web.
Mm-hmm.
So the initial focus has been on games and game engines, but definitely any application from a productivity application to, say, parts of a game engine, like a physics engine or an individual library, etc. So that's kind of been the main goal, just to let people bring native code to the web, to make it as easy as possible, and to make it run well.
Right. Recently, well, a while ago, actually, I saw someone compiling the layout engine that it's used in React Native to WebAssembly, and then they use it to basically have similar compatibility in terms of layout and use it in the browser, basically.
Yeah, I think I saw that. Yeah, it's really cool. I mean, obviously it doesn't have accessibility and other features the way you'd want on the web, so probably most websites wouldn't use something like it, but it does give you exactly what you get with React Native normally, which is a very interesting use case. Yeah, and really the only way to get it is to port the existing native code to the web as opposed to trying to recreate it. So I think it's a nice kind of.
Microsoft have done something quite interesting in that area too with Blazor. I don't know if you've seen this, but they've ported the .NET interpreter to WebAssembly, compiled it basically, and then they deliver .NET assemblies over the web to the runtime, which is running as a WebAssembly module in the browser, which again interprets the .NET assembly and runs it. And then they have solved a very interesting problem in a way that wouldn't be possible. But I don't know if they used Emscripten, but what attracted us to Emscripten as a toolchain was it fit in really nicely with CMake. And everybody that is using CMake which is a lot of people these days with modern C++ kind of pushing it, I think, it really drops in quite well there. Was that something conscious choice to use CMake as to have those wrappers for CMake in there as being a large proportion of users in the world, or was it just something that somebody asked for?
So I think in general, we've tried to integrate with build systems as much as possible. So we have kind of helper scripts like emconfigure and emake that help you integrate with configure and make. And the configure script happens to work with CMake. And we have had a bunch of people that have worked on our CMake integration support. So it has definitely been something that we know a lot of projects use, and we've tried to support well.
Yeah, I think if there's people out there who are interested to dip their toes into this, that do use CMake or even make and configure, they really should know that the support for that is really great and makes it very easy. Even in the early days when those of WebAssembly, when it would produce modules which would not necessarily run in every browser before we got to the MVP. But that side of things worked very well from beginning, from my experience, at least porting our code. And we were wondering like where you think we're probably going to go in the future with this. So you meant a project you're working on is Asyncify. Can you tell us a little bit about that?
Yeah, sure. So Asyncify tries to help one of the big problems that we see, that at least my impression is that a lot of people hit when they try to compile code to the web, that if you take some native code that does, say, file IO, so it does fread probably. Fread is a synchronous call, but on the web, if you want to fetch a file, it's an asynchronous call. there is kind of this mismatch between synchronous and asynchronous that can be pretty annoying when you try to port code. So what Asyncify does is it turns sort of synchronous C code into asynchronous code without you needing to refactor your code base at all. So you can do something like call from C into JavaScript, and it will actually pause the C code, wait for the asynchronous JavaScript event to happen, so the JavaScript event loop just runs normally. And then when the fetch or whatever asynchronous operation you've asked for ends, it resumes the C code. So from the perspective of writing the C code, you've just written normal synchronous code, but you've integrated with an asynchronous event loop. And that helps with a bunch of things like calling web APIs and et cetera. So yeah, it's a pain point that I've seen many times, and this tries to help. Asyncify is actually kind of our third solution in this space. We had an earlier version of Asyncify many years ago, and then we had the interpreter, which solved it in a different way. So this kind of is our third generation of tool just to help with this problem of sort of synchronous, asynchronous, because it's such a common problem.
Giuseppe, you wanted to ask something about some languages as well.
Oh yeah, I guess we've been talking about web a lot, and I asked you in the past, but I wanted to know what, apart from the known languages like Rust, C, and what kind of language you see there that could be the closest to JavaScript that can compile to WASM, and is that assembly script?
Yeah, so I am very interested in languages like AssemblyScript because I think it has the greatest potential for bringing existing web devs to WebAssembly. So I mean, languages like C++, Rust, Go, that have good WASM support today are good, and some web devs might be interested to pick them up. But I think a lot more will be interested in something like AssemblyScript just because it's looks like TypeScript, it's similar to what they know. So personally, I predict that that'll end up being one of the more common sets of languages used by people that compile to WebAssembly.
Right.
And I think there, oh, sorry.
Sorry.
Yeah, no, I just wanted to add, I do think there's a bunch more work that I think will probably happen on the WebAssembly spec side, where we'll add more features to support more languages. It'll make it easier for even more sets of languages to come to WebAssembly. But among those, again, yeah, I think the ones that are similar to JavaScript could end up being very important on the web specifically.
Right, and what's the story around distribution at this point? Is there I believe there is no official registry for WebAssembly modules. Probably people the web folks are like distributing modules with on NPM along with other packages, but is there any work being done in that sense that you're aware of?
So I'm aware of it. Yeah, there are a bunch of sort of projects in this space that I'm aware of, but I don't know that much about. So there are people that on NPM just bundle WASM either as part of JavaScript or by itself. There's also in the non-web space, there's something called WAPM, the WASM Package Manager, which focuses on the server side of things. So it's kind of early in this space for figuring out sort of a solution for packages. And we're still kind of figuring out, I think, on the toolchain side exactly how these things will work. So it's pretty early, but people are sort of finding things that work and doing them, I guess.
Speaking of tools and toolchains, how do you think progress is in terms of like debugging environments, and is that going to, personally I find that that's the weakest point, which is quite typical in the new technologies like this, but there's big progress made, and do you think things like AssemblyScript will make that easier, or maybe help bring more people in, because of course you cannot do everything yourself?
Yeah, so first, yes, the debug story has been something that I've definitely noticed a lot of people have issues with, and we've wanted to do more. I'm actually starting to work on that myself currently to try to push that a bit forward. So I do hope that'll get better. At least I'll do my best to help there. Specifically, I'll kind of work on integration of debug info in Binarian, which will help Emscripten and AssemblyScript and other projects that kind of use the Binarian toolchain one way or the other. So I hope things will get better there. But yeah, the debug story is fairly complicated. There's a lot of pieces that need to work together for it to really be comparable to the native debugging story. But I hope that we'll get there.
Yeah, having said that, I've found just empirically that because our code is cross-platform and I can compile and debug an issue on one platform, it typically is behaving the same way on WASM. So that hasn't been a huge blocker. I wouldn't want to communicate to anybody that they should wait for that. I think that it's really, they should really try it out already, even if that's for them a difficulty. Perhaps not, threads notwithstanding, but that's something. That's something that's, again, personally, I almost feel like I hope that threads don't become a big thing in the WebAssembly world, because it makes life easier to reason about. But that's a different thing. Yeah. Sorry, go on.
No, yeah, I mean, debugging something like threads certainly gets harder. It is tricky. Yeah.
Yeah. 20-something years of engineering, and I still don't find that very easy. Yeah, as Giuseppe said earlier, we were in PSPDFKit pretty early adopter for a productivity framework and app company to jump into the WebAssembly world. The games industry really took it early and did a lot of great work there first. But I have a kind of a last two-part question for you. What areas of the software industry currently could benefit the most from adopting WASM, and they don't recognize that benefit yet? Because we could spread this a bit further, I think.
Yeah, I mean, so that's a fairly big question, but it's a very good one, I think. So one thing that I bet on is I suspect that there's a lot more to be done in actually the areas that have already done a lot, like games. So for example, we do see many game engines being ported to the web, but you don't see the game development tools themselves running on the web. I think they could too, and that could actually be very interesting for various reasons. Aside from that, one area that I think is maybe underappreciated now, but I think could be huge for WASM, is the area of plugins. So many applications need plugins of some sort, like, I mean, game engines are a classic example, but even aside from them, an image editor could have plugins that do image filters. WebAssembly is really great for this because there are great tool chains, great virtual machines to embed in your project. So if you just embed a WASM VM, you can support plugins written by many languages and support them in a safe and secure and portable way. So I think we're going to see a lot more of that. I keep hearing about activity in this space, and it really is something that WASM is a great fit for, I think.
Yeah,
So,
that makes logical sense. You could imagine easily a web-based photo editor or even movie editor that would allow third-party plugins to be dropped in as WebAssembly modules.
Yeah, exactly. Yeah, it's really a very good fit for that case. And again, even
actually the Chrome team, someone in the Chrome team made a web app that basically allows using WebAssembly allows you apply images, effects to images, and the sort of things I can't remember the name.
do you mean maybe the Squoosh app for sort of shrinking images?
Oh, I think that one. Yes, that might
be that. Yeah, then that's kind of a nice example of a website that uses WASM. It has like multiple code bases ported to do different applications. Yeah, it's very modular. Yeah, it's a good example of this. Yeah.
Yeah, that sounds really good. Yeah, I mean, I think we've covered a good section of the history and the use cases there, and I hope that we can intrigue other people who listen to this to really have a closer look at it, because it's incredibly powerful, and no doubt will be even will become a huge and important part of the web going forward. And not just the web, but even seeing things like we're starting to see server-side deployment of WASM modules as well. But yeah, thanks a lot, Alon, for the amazing job you've done and the work, and others, of course, and making that technology a really great success. It helped our company a lot. We really appreciate that. And it helped us make something better for our customers, which is why we, myself, Giuseppe, and the whole team really are enthusiastic about this technology, and hope that we can transfer some of that enthusiasm to other people. So yeah, again, thank you very, very much.
Great, thanks. Yeah, it's really it's really good to hear those things. Thank you.
And for your open source projects, like Emscripten, I believe is open, right? And gets contribution from all over the place, right?
Yeah.
I think people should check it out and
yeah,
see how we could fit their use cases and maybe even contribute.
Yeah, it's 100% open source, and a lot of work is done just by outside people that contribute a patch or two. So we're always happy for people to file bugs or submit PRs. Definitely.
Yeah, and I can say it's a very friendly and helpful bunch of people. They've been very good to me as we started on that road. And we made our small contributions, but they were very appreciated, and that's a good feedback loop.
Thank you. Yeah.
And to close off, if anybody wants to learn more about yourself, where can they find you, or your work actually?
Well, Emscripten.org is like the main website, so that should have links to everything there.
Brilliant.
Nice.
Thanks again.
Thank you.
Thank
Bye.
you.